Hello, we are from Group 3. We'd like to present our experiment, which is the effect of salt on the boiling temperature of water. My name is Intan Nur Anissa binti Muhammad Zalani, and my other two group members are Vignesh and Mugundin. So, what is the aim of our experiment? The aim of our experiment is to investigate the effect of salt on the boiling temperature of water. And we want to find out the relationship between the amount of table salt and the boiling temperature of water. So, in this experiment, we have chosen two factors that we want to investigate, which are we change the volume of water to 500 ml and 1000 ml, and the second one is we change the amount of table salt. So we want to see how the temperature will be affected by using these two variables, whether it decreases or increase. So this is the example. This is the setup of our experiment. So the salt and the distilled water will be put in the beaker, and it will be heated by using Bunsen burner. And we will observe uh, how much the temperature rises or decreases. So next, Vignesh will explain the result. That's all from me. Thank you.
Now I'm gonna explain about the result. So the first table shows that what will happen to the temperature of boiling point of water when the amount of table salt is changes. We know that the constant will be the volume of distilled water, which is a 500. So the amount of table salt changes from 50 to 100 and 150. So the average temperature of boiling point of water is 102.4 when 50 gram of table salt is added into water. When we add 100 gram of salt, the temperature will be 103.5 degrees Celsius. When we add 150 gram of salt, the temperature will be 105.3 degrees Celsius. So we can easily understand from the bar chart where when the amount of table salt increased from 50 to 150, the temperature also slightly increased from 102.4 to 105.3 degrees Celsius. This is because the salt is contained two different ions, which is a sodium and chloride ion. These both ions will help to break down the bonds between the water molecules. To break down the bonds, the ions require more energy. So this energy will cause the temperature of boiling point of water to slightly increase from 100 degrees Celsius until 105.3 degrees Celsius. This graph shows another method to easily understand about our result. So we're using the box plot method. Okay. Okay. Next table, when we're using 1000 milliliter of volume of distilled water. Previously, I showed that table 1 is constant is the volume of distilled water at 500 milliliter. This table shows the same constant, which is the volume of distilled water, but at 1000 milliliter. So the amount of table salt is also changes from 50 to 100 to 150. So when we're using 50 gram of table salt, the average temperature will be 101.1 degrees Celsius. When we're using 100 gram, the temperature will be 103.8 degrees Celsius. Last but not least, when we're using 150 gram, the temperature will be 104.8 degrees Celsius. This is another type of bar chart. So when the temperature increased from 50 to 150 at 1000 milliliter of water, the temperature is slightly increased from 101.1 to 104.8 degrees Celsius. Okay, now I'll be explaining about the ANOVA table. Okay, from here we have already tabulated a table for the ANOVA table based on our table 1. Table 1, which is our variables is 500 ml of distilled water is which will be added with 50 gram of table salt, 100 gram of table salt, and also 150 gram of table salt. From this table of ANOVA, we do know that the value f denotes as the test statistics, and to get the value of f, we need to divide the mean square between the groups, which we get 8.395833, divided by the mean square within the groups, which is 0.104167, and we will get the test statistic f as 80.6. Okay, based on this test statistic, we do know that when we have a large number of test statistic, when we compare to the F critical, this shows that our hypothesis is not accepted. This is because one of the reason is that the mean square between the groups is higher than the mean square within the groups. Okay, next we'll be comparing the p-value with that alpha 0.05. Okay, that is also can be considered as one of the factor why we did not accept our hypothesis. This is because the p-value that we have obtained in this ANOVA table is 1 times 10 to the power of -5, which is smaller than our alpha, which is supposed to be 0.05. So this is one of the main reason why our hypothesis is not accepted. Okay, next we'll be move on to the next ANOVA table, and this ANOVA table is referring on the table 2, which is we are using 1000 ml of distilled water, which will be added with 50 grams of table salt and also 100 grams of table salt, and finally 150 grams of table salt. From this table also, it shows the similar case where our test statistic f has the highest value, which is 106.6232. To get this test value of test statistic f, what we have to do is that we need to divide the mean square between the group, which will be divided with the mean square within the group. Okay, from this ANOVA table, our p-value that we have obtained is 5.49 times 10 to the power of -7. So our p-value is much more smaller than our alpha value, which is 0.05. So we do also know that our f, which denotes as the test statistics, is much more bigger than our f critical that we have obtained in this table. Okay, based on these two ANOVA table that we have plotted, we do know that both of the hypothesis is not accepted, which is not true. This is because the test statistics for both ANOVA table is bigger than the F critical. So the reason why we did not accept our hypothesis is that it might contain impurities in our experiment while we're conducting this experiment. And another reason why we are not accepting this hypothesis is that there might be an error which is called the parallax error, where our eye position is not perpendicular to the scale of the meniscus of the thermometer. So that is the two reasons why we are not accepting the hypothesis for this experiment. Now let us move on to the conclusion. Okay, in the conclusion, we have tested that the effect of salt to dissolve in the boiling point, in the boiling temperature of the water is based on our table 1 and table 2. We do know that when the amount of the salt increases, the temperature of the water which requires for the salt to be dissolved will also increases. So this wraps up our presentation, and I hope that you've enjoyed our presentation, and that's all from me. Thank you.